Hey everyone, and welcome back to the channel. Today we're diving into the world of artificial intelligence, specifically how AI makes decisions in games like chess or tic-tac-toe. But before we jump in, imagine you're playing a game, any game, and you want to make the best move possible. You start thinking ahead. What if your opponent makes this move, then what do I do? What if they make that move instead? It can get complicated fast, right? Well, for AI, this thinking ahead can become a tangled mess of possibilities. That's where alpha-beta pruning comes in, and it's about to change the game, pun intended. Let's break it down step by step. Meet Minimax. Before alpha-beta pruning, AI used something called the Minimax algorithm. Here's the idea. Minimax looks at all possible moves, assuming your opponent will always make the move that hurts you the most, like a super sneaky opponent. Here's the twist. Your turn, max level. You want to maximize your score, so Minimax picks the move that gives you the best outcome. Opponent's turn, min level. Now it's your opponent's turn and they want to minimize your score. So Minimax picks the move that hurts you the most. Minimax keeps looking ahead for several moves, like going down several levels of the tree, and finally picks the move that leads to the best outcome for you, considering your opponent's sneaky tactics. But here's the problem. Minimax can be slow. It has to explore every single branch of the tree, which takes a lot of time, especially for complex games. Enter alpha-beta pruning. This is where things get exciting. Alpha-beta pruning is like a magic pruning shears that cuts away unnecessary branches, making the decision process way faster. Here's the secret sauce. Alpha. This represents the best score you can guarantee so far. Think of it as your best apple you've found on the tree. Beta. This represents the best score your opponent can guarantee so far. Imagine it as your friend's best apple they've found. Pruning power. Now, as we explore the tree, alpha-beta pruning keeps track of these alpha and beta values. If we find a move that's worse than a move we've already seen, worse than your best apple or your friend's best apple, we can just prune that branch. Why waste time exploring something that won't be the best outcome anyway? Real-life example. Imagine picking apples. You find a juicy red one, score 8, that's your alpha. Then your friend snags an even better one, score 9. That's the beta. Now, if you see another apple that's not as good as your first one, score 7. You wouldn't pick it, right? You already have a better one. Same with alpha-beta pruning. It helps AI avoid wasting time on moves that won't be the best. We'll put all this to action with a cool visualization. We'll see the tree, how alpha and beta values change, and exactly which branches get pruned. So smash that like button and subscribe for the next part, where we'll see alpha-beta pruning in action.